All right, in this video I'm going to be talking about the chain rule, a way to deal with derivative of composite functions. But before we start and give you the rule and do some examples and stuff, I've got a question for thought. Just which of these functions do we know how to take the derivative of at this point, right? Are there any that you can see that we don't know how to take the derivative of? Yes?
Sine x.
Sine of x squared, the purple one, right? What about the green one? Can we take the derivative of that one? Yeah, you could if you did a little bit of work first, right? But what about red and blue? What's the deal with red and blue? Yeah, those are the product quotient rules that we learned last time, all right? So we know that with the one in green, if we were to, do some algebra like distribute the x squared plus 3 times x squared plus 3, or maybe use the product rule, we could take the derivative of that. You could do that. Red is product rule, blue is quotient rule, but purple, we don't know how to do that yet, right? Because there's something different about, taking a number and squaring it and then taking the sign of it. There's something different going on there. And so really, it's the fact that we're squaring it and then taking sign of that. It's that composite function that we need a new rule for. And that rule is going to be the chain rule. Now, again, just like with all the rest of the videos and all the rest of the rules and the proofs and stuff, the proof of this rule will be as a separate video. If you're interested, then you can go into my channel and look for, chain rule proof video. But I'll tell you, it's going to be algebraic, and it's not going to be all that interesting. It doesn't give you any additional insight into why the rule is true. It just shows you how it's true. Okay? So the derivative of f of g of x is, you're going to take the derivative of the outside function, which in this case is f. You're going to leave the inside the same. Now, what I'm going to try to do in most of the examples today, I won't keep doing this throughout the course of the year, is I'm going to try to label the inside in square brackets. Okay, so f prime of g of x, and then I'm going to multiply by the derivative of the inside. Because we've got to account for that somehow, right? Because the derivative of sine of x squared is not going to be the same as the sine of x. Right? Just got to do something different there. All right? And this is a rule that I don't think that we necessarily need to commit this one to memory. I mean, we do, but if we just practice it a bunch, we will get better at it. And I'm going to tell you right now, if you're brand new to calculus and you're just starting to do derivatives using the chain rule, you're going to make some errors. It's going to happen. It's not a question of when, of if, but when. You're going to make some errors at first, and the best way to work through that is to just keep practicing. You got to practice, practice, practice. It's like with anything, right? At this point, y'all are in need of taking a million derivatives. You got a lot better at the product quotient rules over the past couple of days, right? And the chain rule is going to be just like that, all right? The only other thing I'm going to add to this is I'm going to write that, and some people, this is kind of, old way of looking at it, but you might like this. I've heard that certain physicists at this school like to write it this way, that dy dx is equal to dy du multiplied by du dx. You might like that because you think, oh, maybe I could cancel off the du's if, such a thing is permissible, which, it's not, but that's just my own personal gripe. But right, where u is the inside function, where we take the derivative of y with respect to u, leaving u the same, but then we multiply by the derivative of u with respect to x. All right, so the first example I got for you is y equals sine of x squared, where x squared is the interior. Okay, I made sure to put that in square brackets. Find dy dx. Okay, well, I can do that. What I'm going to do is I'm going to obey the chain rule. I'm going to take the derivative of the outside. Okay, the outside is sine. Okay, so I'll take the derivative of sine, and that's cosine. Right? So I'm taking the derivative of the outside. But I'm going to leave the inside the same. But then I'm going to need to multiply by the derivative of the inside, that x squared. So I'm going to multiply by the derivative of x squared, which is 2x. Yes, good. Wonderful. Right, so we've accounted for both of the derivatives, and we've obeyed the chain rule. Now the thing is that whether you are sitting here in my classroom right now or you are at home watching the video, watching me do derivatives using the chain rule is not going to be enough. You can watch me do derivatives all day long. You can be like, yes, I follow you. I see what you're doing. And then you can go and sit down to do it and find, well, I might actually not know what I'm doing. Okay, so I'm going to need y'all to do most of these examples, because if you make the errors in here, where I can, show you where you're going wrong, you'll know what to look for, right? You'll know what your common errors look like, right? Okay, so starting with that, we're going to give y'all an example to work. All right, so if f of x is equal to the square root of 5x to the fourth plus 4, find f prime of 1. Well, I'll help you, get you started in the right direction. Okay, right, we need to rewrite this as f of x is equal to 5x to the fourth plus 4 to the 1/2 power. Okay, so it's a little more obvious what the outside and the inside is. Okay, the inside is going to be the 5x to the 4 plus 4, and then I'm taking the square root, taking it to the 1/2 power. Okay, at this point, I'm going to freeze the screen in class, and those of you all watching at home, you're going to need to pause the video right now because the answer is just going to pop up in like 5 seconds. All right, there's the derivative. We'll plug in 1 here in a second, but remember that the derivative of a thing to the 1/2 power is 1/2 times that thing to the negative 1/2 power. All right, so the derivative of 5x to the fourth plus 4 to the 1/2 power is 1/2 of 5x to the fourth plus 4 to the negative 1/2 power. But then we have to remember the derivative of 5x to the fourth plus 4 for the chain rule. That's that 20x to the third plus 0. Right, now this is fine. If you wanted to, be a little fancier with it, you could multiply the 1/2 and the 20, and that would be 10x to the third. And the negative 1/2 power, is going to send the thing down into a denominator, and it's going to turn into a square root. So you could write it like that. You wouldn't be any more right, but it might be easier for you to work with if you had to say, plug in 1 or something like that. Okay. So then f prime of 1 is going to equal 10 times 1 to the third power divided by the square root of 5 plus 4. Okay, that's 10/3. Now, what I will say about this is you might be wondering, like, wait a minute, dude, like, didn't you say I could just, go over here and say f prime of 1 was 1/2 times 9 to the negative 1/2 times 20 times 1? It's like, yes, you could have written it like that on the quiz or on the free response section of the test or whatever. But think about when you got a mostly multiple choice test coming up, are the multiple choice answers going to look like that? Or are they going to be 10/3? It's going to look like 10/3, okay? All right, so next I'm going to ask you another kind of question for thought. Thinking back to your pre-calculus class, what's the difference between sine of x squared, sine squared x, and sine of x squared? Are they all different? Are two of them the same? Well, what's going on here? The first two are the same. Yes, you must have had a good pre-calculus experience. Okay, I'm glad to hear it too. It seems like your calculus experience so far has been pretty all right. So the first two are the same. That is completely true. Sine of x squared and sine squared x are the same thing. They are both the same as taking the sine of x and then squaring it. I mean, I seem to like square brackets, but I think that would be the best notation, right? But in the old days, they might not have had that for their typesetting stuff, and so they did sine squared x. I've also seen log squared x, just to avoid the confusion. But you could see the confusion between the first one and the third one if, especially if there were no parentheses, right? If there were no parentheses, you have no idea which one they were talking about. Right? So we don't want to be unclear. All right, so we already took the derivative of the third one as the first example we did. So maybe we need to look at the derivative of sine squared x, which is something we may have done last time using the product rule, depending on which section you're in. All right, so let's take the derivative of sine squared x. And actually, looking at the statement of the question, let's take the second derivative of it too. I remember where I was headed with this. Okay, I've got some things to add here. All right, y'all try it on your own. If you're watching at home, you need to pause the video because again, in 5 seconds, the answer is going to pop up, or at least the first derivative. All right, there you go. So I rewrote it with squared brackets because I like to do that. And so I wrote it as y equals sine of x squared. Okay, now I know that the derivative of a thing squared is 2 times that thing to the first power. That's the power rule. But then I also didn't forget to multiply by the derivative of the inside for the chain rule, right? So that's where I get 2 sine x cosine x. Now, I'll tell you, I've told you this already, I think, the best time to really learn something is right before you forget it, right when you're about to forget it, okay? And the product rule, I'm not saying you're right about to forget it, but we're moving on. We're doing chain rule. We're going to do derivatives of inverse functions. Don't forget to practice the product rule and the quotient rule. So how about now you take the second derivative of dy dx, the second derivative of y, by taking the derivative of dy dx using the product rule. There shouldn't be any chain rule here, right? And if you're watching at home, pause because 5 seconds, you know the drill. All right, there you go. So I used the product rule, right? I took the derivative of 2 sine x, that's 2 cosine x. I left cosine x the same. Then I added in, leaving 2 sine x the same, the derivative of cosine x, which is negative sine. Okay, now that gives me 2 cosine squared x minus 2 sine squared x. And you might be thinking, that looks familiar. Does that look familiar? Does 2 sine x cosine x look familiar to anybody? Yes, just saying it looks familiar. You might be thinking of the double angle formula. 2 sine x cosine x, that's sine of 2x. If you don't remember that, no big deal. If you do, you must have had a really good pre-calculus experience. What I'm going to say about that is if you remember that this is equal to the sine of 2x, well then you could take the second derivative more easily using the chain rule. And actually taking the derivative of sine of 2x is much more common than some of these like really complicated examples we're going to get into with multiple layers of chain rule, multiple rules at once. This is a very common thing for AP Calculus to need to take the derivative of using the chain rule. Something where the chain is actually just a constant multiple on the inside of a function, like sine of 2x or e to the 10x or something like that, you know? So that means that the second derivative is going to be, okay, I'm going to take the derivative of the outside, that's cosine, leave the inside the same, and then take the derivative of 2x, which is going to be 2, because 2x is a line with slope 2. Okay, and this is 2 cosine of 2x. And if you really think back to pre-calculus, you remember that like cosine squared x plus sine squared x was 1. I think everyone knows that, or at least everyone in pre-cal knows that. But cosine squared x minus sine squared x is kind of the one that you wanted to be able to do something with, but you weren't able to for a long time. And then they were like, well, you know, we'll tell you it's a double angle formula, and that these are actually the same thing, the two things I just highlighted. So you can show that they're the same, you can do it either way, as long as you know your trig identities. And I know that they're the same, so it doesn't really matter. For this class, you don't have to really know any of the trig identities, besides that, like, you know, tangent is sine over cosine, and cosecant is 1 over sine, stuff like that. All right, next I got one for y'all to practice with. The derivative of cosine of 1 over x. Except I don't like how this one's written. Right? If you go to take the derivative of cosine, and then you go to, you know, leave the inside the same, and then multiply by the derivative of the inside, and you want to use the quotient rule, I think that would be a waste of your time. Okay? I'd rather use the power rule. And I kind of said that I was going to, you know, basically use square brackets for the inside. So let's rewrite this as the derivative with respect to x of cosine of, what's a better way I could write 1 over x in terms of x to the negative first, so I can use the power rule, right? Because as we know, we prefer to use the power rule over the quotient rule, if at all possible. So I'm going to say that this is cosine of x to the negative first power. And, well, I'll start by taking the derivative of the outside, but actually, why don't you do that? If you're watching at home, I'm actually not going to pause the video on this one. I'm just not going to narrate. I'm going to freeze the screen for people in class. But if you want to follow along with me, you can. If you want to try this yourself, just, look back, look away from your phone, and then look back in a few seconds. All right, there it is. So what I did was I took the derivative of the outside, which is the derivative of cosine, negative sign, and I left the inside the same. And then I multiplied by the derivative of the inside. Well, the derivative of x to the negative 1, I'm going to use the power rule. I'm going to bring that power around the front. That's negative 1, x to the negative 2. Right, we got to reduce the power by 1. So what you could do, you could, if you were feeling really fancy, you could multiply the negative by the negative and make it positive. You could have sine of 1 over x. And then you could throw that x to the negative 2 down in the denominator as x squared. And you wouldn't be really any more right than the equality above it. But, if you're thinking about multiple choice test, you might want to be able to recognize that they are equivalent. Right? So I'll just point that out. Question was, how did I get x squared in the denominator? And that was from x to the negative 2 right there.
Yeah, well.
Because that's what x to the negative 2 is. It's 2 powers of x in the denominator. It's the thing that if I multiplied it by x squared, I would have 1. All right, let's go into some more challenging items, like multiple layers of chain, okay? This is not really something that's all that common, but I can guarantee you on the test, a couple times from now, there's going to be a problem that has more than one layer of chain. Okay? So what I did for this one, I just already wrote it down for you, sine cubed of 4x squared. Well, I'm going to write this as, what we're doing is we're taking x and we're finding 4x squared, then we're taking the sine of it, and then we're cubing that. So I wrote it that way to kind of show you what's going on. And then, I use some color to differentiate each layer of chain. So when I go to take dy dx, I'm going to kind of just set up for each layer and then, show you how it will go. Right? If I'm going to take the derivative of it starting from the outside, take the derivative of a thing to the third, it's 3 times that thing to the second power. That's the power rule. Then, if I've got wanting to take the derivative of sine of a thing, well, I know that that's cosine of a thing. And then, I'm going to have to connect these things with multiplication, and there's going to be a derivative of the red level, okay? Then I'll do that eventually. So what I'm going to do, the way the chain rule works, is we take the derivative of the outside and we leave the inside the same. So here I am, sine of 4x squared, I'm going to leave that the same. Then when I take the derivative of sine of 4x squared, I need to leave the inside, that 4x squared, the same. Okay? And then when I go to take the derivative of 4x squared, well, that's looking like 8x to the first. Okay? Now, if this were in a multiple choice setting, this is really probably not what the answer choices would look like, right? Probably what you're looking at is combining the constants, so that's the 3 and the 8, making 24, and writing sine of 4x squared, then squared as sine squared, 4x squared. I feel like that's how it would most likely look in a multiple choice setting. Yes, 24x. Yeah, they would probably move that x out front. Thank you over there in the corner. That was, could have been a video ruiner, right? 24x sine squared, 4x squared, cosine 4x squared. Answer. All right, here we've got multiple rules at once. We've got product rule, and there's going to be chain rule on the second factor. So what I'm going to do is I'm going to go over here, and I'm going to switch up the color to gray. I'll take the derivative by, I'll start with the easy one, life short. So I'm going to take the derivative of x squared, that's 2x, and I'm going to leave 2x to the third minus 1 to the fourth the same. Then I'm going to add in, leaving x squared the same, I'm going to take the derivative of 2x to the third minus 1 to the fourth, which is going to be 4 times that thing to the third power. Then I'm going to multiply by the derivative of the inside afterwards. So that's 2x to the third minus 1. Leave that the same. But then I'm going to multiply by the derivative of 2x to the third minus 1, which will be 6x to the 2. All right. And now I've got all this stuff. Well, I need to, if I'm preparing for a multiple choice test or whatever, I'm going to need to kind of combine like terms, especially on the second factor. So I'm going to write this as, I'm going to leave 2x times 2x to the third minus 1 to the fourth the same, plus 4 times 6 is 24. X squared times x squared is x to the 4. And then I have 3 powers of 2x to the third minus 1. All right. In general, on this type of question, on the College Board items, they're going to factor the answer. And so I'm going to do the same thing here. I'm going to think to myself, oh, hold on, I lost an exponent along the way. That's a third power of that thing in square brackets. I'm going to think, what do I have in common to all three? Well, I definitely have 3 copies of 2x to the third minus 1, right? I also have 1 power of x. So I'll factor that out. And then lastly, I'm going to see I have 2 and 24, so I could probably factor out the 2. So I plan on factoring out all 3 of those things. Okay, so I'm going to factor out the 2 and the x and 3 powers of 2x to the third minus 1. Okay, and what am I left with? I'm left with 1 power of 2x to the third minus 1. Plus, okay, well, factor out the 2 from the 24 and I get 12. Factor out the x from the x to the fourth and I'm left with 3 powers of x. And that's it, because I took all 3 powers of the thing in square brackets. Right? And then I can say, okay, well, that's going to be 14x to the third minus 1. Can combine like terms. And I don't know what the equivalent version of this question on the test is, but you'll be sitting there and saying, like, where are we getting 14x to the third from? Especially if all you had was like this or that. You're like, where are we getting that? I don't see 14 anywhere in this picture. It's because you need to factor. All right, next we have another example that doesn't seem to really fit in with the chain rule, but it was on my notes from last year. So it must be very similar to some kind of question on like maybe a quiz or a test or something. So we're saying that f is differentiable, and the graph of the line tangent to f at 3, 6 passes through the point 5, 28. And they're asking us for the sum of f of 3 and f prime of 3. Well, what I'm going to do is I'm going to just kind of like draw a little diagram. Okay, well, here's the graph of f. Maybe I'll draw the line tangent to f like that. And maybe that's 5 and 28. Okay. The point it passes through is 3, 6. And, okay, so if we're sorry, I'm just going to do this piece by piece. Okay, so f of 3, what is f of 3? Well, f of 3 is the y-coordinate of the point on the graph of f where x equals 3. So that's going to be 6. F prime of 3. Now think about how am I going to get f prime of 3 here? Because they didn't really tell me about the slope of f, the slope of the tangent line. But wait a minute, they gave me 2 points on the tangent line. The tangent is a line, right? And the line has a constant slope. So I'm going to go back and I'm going to think back to algebra 1. I'm going to do some rise over run. So this is going to be 28 minus 6 over 5 minus 3. So that's 22 over 2, which is 11. So now I'm ready to do the addition that they requested. We're going to say that f of 3 plus f prime of 3 is 6 plus 11, which is going to be 17. So I guess I thought I'd just sneak that example in there. All right. Now I'm going to talk to you about the derivative of like 2 to the x or log base 2 of x. This is something that is very unlikely to show up on your AP exam. Not likely to show up in this class because, like I've said, the only exponentials I really care about have base e, and the only log I care about is natural log. But maybe you're in a science class and you need to look at a log with base other than e, or an exponential function with base other than e. I know that in half-life it can be useful to use a base of 1/2, right? That's not out of the realm of possibility. So what I'm going to do is I'm going to show you how to take the derivative of 2 to the x. First thing I'm going to do is I'm going to point out that 2 is the same number as e to the natural log 2. That's kind of an identity, all right? That's what the natural log of 2 is the special exponent I put on e to get 2. So I'm going to put that special exponent on e, and I'm going to get 2. So 2 to the x is going to be this number to the x. When you think back to your algebra course, you remember that this situation right here is where you multiply the exponents. So I'm taking the derivative of e to the log of 2 multiplied by x. Now, if I was taking the derivative of e to the 10x, that would be e to the 10x, but then I would have to multiply by 10 for the chain rule. So I'm going to do the same thing here. This is going to be e to the natural log 2 multiplied by x, but then I'm going to have to multiply by the natural log of 2 because of the chain rule. Okay. Then I'm going to go back and I'm going to block off e to the natural log of 2. Well, that's 2. So what this is this is 2 to the x, except multiplied by the natural log of 2. Okay. So really the rule in general for the derivative of a to the x is natural log a multiplied by a to the x. I can never remember that though, and I do teach CalBC every year, so you might have a hard time remembering it too. The better way is to just remember that you can transform 2 or any number into e to the log of that, right? I guess provided it's positive. But a valid point also at the same time, -1 to the x or -2 to the x is suspiciously a function that just is not studied in any of your math classes. If you think about it, right? It jumps back and forth. So, that's just something for you to think about. Now let's look at the derivative of log with base 2 and argument x. All right? And I'm going to ask you to think all the way back to probably an algebra course where you learned about the change of base formula and then forgot about it, unless you were in that type of really mean college algebra course where I was the teacher and I only gave you a scientific calculator which didn't have the log base command. So they had to learn the change of base formula if they wanted to evaluate logs using the calculator, which of course they did. So what you do is you say that this is natural log of x divided by natural log of 2. It's x is on top and 2 is on bottom, because if you look at the way we write log with base 2 and argument x, well, x is on top and 2 is on bottom. But log of 2 is just a number. So really what this is the derivative of 1 over the natural log 2, which is just some other number, multiplied by log x. And I know that I can take the derivative of a constant multiple times a function by just constant multiple times the derivative of the function. So this is 1 over log 2 multiplied by 1 over x. So the rule in general is that the derivative of log with base b and argument x is going to be 1 over the natural log of b multiplied by 1 over x. Okay. And that's just something I'd throw in there. All right, now I'm going to go in, I'm going to do a couple of multiple choice questions and a couple of free response questions, and I know that this video is going to go over a half hour, which I really try to avoid, but for the sake of preparing you for the test, I'm going to throw in a couple of more examples. All right, first let's look at 2016 AB number 6, which is a no calculator question. go to table, it's given values of functions and functions f and g and their derivatives at a few values of x, right? And I'm going to do part A because it has to do with the chain rule. It's the chain rule video. But if you look at part B, I gotta point this out. It's a quotient rule question, and it's g of x divided by f of x, just like I told you in the product rule and quotient rule video. That's how it's going to go on the AP exam, on my test. We're always going to ask you about the derivative of g divided by f because we don't want you memorizing it in terms of, just letters. I want you to be more conceptually aware that it's bottom times the derivative of the top. So I just got to point that out. But what I'm going to do is I'm going to say, okay, k of x is f of g of x. So I need to start with a point if I want the line tangent to the graph of k at x equals 3. So I need a point. That's going to be x equals 3 and k of 3, which is f of g of 3. Well, g of 3 was 6. So I'm looking for f of 6. And I plug in 6 to f, and that's 4. So this is the point 3 and 4. Okay, in order to get the slope, okay, I'm going to need a derivative. So the derivative of k, I'm going to need to use the chain rule. I'm going to take the derivative of the outside while leaving the inside the same. And then I'm going to multiply by the derivative of the inside. Okay. Meaning that k prime of 3 is going to equal f prime of g of 3. We already know is 6. Because we looked it up the once, no sense looking it up twice, multiplied by g prime of 3. Okay, so that's f prime of 6, and then what's g prime of 3? Okay, I'm going to go to g prime, go down to 3, that's 2. So that's multiplied by 2. Okay, f prime of 6 is looking like 5. So it's 5 times 2, which is going to be 10. So now I'm ready to write my equation. That's going to be y minus the y coordinate, so y minus 4, is equal to the slope, 10, times x minus 3. That's a very common table type question. All right, next we've got 2017 AB number 6, and this one's a little wild. We've got a table, we've got a graph, and we've got a function where they gave it to us, and it's a composite function, right? So what I'm going to do is I'm going to actually do part A, right? This is a very chain rule question. So I'm going to say f prime of x is equal to, all right, the derivative of cosine is negative sine. I need to leave 2x the same. And then I need to multiply by the derivative of the inside. That's the derivative of 2x. And then I'm going to add, okay, the derivative of e to the thing is itself, right? So that's e to the sine x. But then I need to remember to multiply by the derivative of sine x. So that's cosine x. So to try to write this all in one line, this is negative 2 sine 2x plus e to the sine x multiplied by cosine x. All right? Then when I plug in pi, because that's going to be the slope of the line tangent to f and x equals pi, I'm going to have negative 2 sine of 2 pi, well, sine of 2 pi is 0, plus e to the sine of pi, also 0, times cosine of pi, which is negative 1. So all of that to get negative e. All right? That's not so bad once you know what you're doing. Now, part B, let k be the function defined by k of x equals h of f of x. Find k prime of pi. Well, first we're going to need k prime of x. And that's going to be, start with the outside, h prime of f of x. Then multiply by the derivative of the inside, times f prime of x. Well, luckily when I go to plug in pi for x, I'll be taking f prime of pi, and I just found that in part A. That's really helpful, or at least going to save us some time here. So k prime of pi is equal to h prime of f of pi. Okay, so I'm going to need to find out what f of pi is. Times f prime of pi, which is just negative e. Okay, I'm just going to make that happen right now. Well, f of pi I'll do that over here. That's cosine of 2 pi, which is going to be like cosine of 0, which is 1, plus e to the sine of pi is e to the 0, which is also 1, so f of pi is equal to 2. So I've got h prime of 2 multiplied by negative e. Okay, well, h prime of 2, h is the graph. I need to go over here to where x is 2, and I need the slope at that point. So that's 2. And the slope, I'm going to have to do a little bit of square counting, but I rose by negative 1 when I ran 3, so it's looking like negative 1/3. So this is negative 1/3 multiplied by negative e, so that's looking like positive e over 3 to me. Okay. If you're interested in product and chain rule at the same time, you could try part C. Let's see. I don't think you know enough to determine the answer to part D yet. I don't believe so. That's the mean value theorem. Unless, let's see. Yeah, they're not telling you that the derivative is continuous yet. You need a little more knowledge to do that one. Let's move on to do some multiple choice questions. Right? Here's a good one. It's number 9 in your multiple choice packet. It's saying the slope of the line tangent to the graph of y equals log of x squared at x equals e to the 2 is one of these 5 answer choices. Well, let's take dy dx. Let's take the derivative and then plug in x equals e to the 2. Right? It's log of x squared. So x squared is the inside and log is the outside. So the derivative of log is 1 over x, okay, or 1 over the thing if you're taking the log of the thing. So this is going to be 1 over x squared multiplied by the derivative of the inside, which is going to be the derivative of x squared. That's 2x. So that's 2x over x squared. Okay. You could also call that 2 over x. That's what I'll do. And so dy dx at the point where x is e to the 2 is 2 over e to the 2, which I'm seeing as answer choice B. All right, number 78's got multiple layers of chain. Okay, so I'm going to rewrite it, using some color. We're going to find f prime of x, but first I'm going to write f. Okay, first I'm going to take x and I'm going to make it negative. Then I'm going to take e to that power, and then I'm going to take sine of that. So sine is the very outside. Then I'm taking e to the some kind of power, and that power I'm taking it to is negative x. Right? So the derivative is going to be, I'm going to start with the derivative of the outside. That's the derivative of sine. I'll leave the inside the same. Then I'm going to multiply by the derivative of the next layer. E to the u is its own derivative, so that'll be e to the thing. And then I multiply by the derivative of the innermost thing. So I'm going to go in, I'm going to leave everything the same. That's cosine of e to the negative x, e to the negative x. And let's see, where was I? Multiplying by the derivative of the innermost thing, that's going to be negative 1. So I've got negative e to the negative x times cosine of e to the negative x. That is answer choice E. Okay, that's multiple layers of chain rule. Here's one that I feel like is honestly kind of more typical, the easier ones where the chain is actually a constant multiple on the inside of a function. Y equals 2 cosine of x divided by 2. They're going to ask for the second derivative, but I think we're going to be able to work with that. So I'm going to start with, the first derivative is going to be 2 times the derivative of cosine of x over 2, which is going to be negative sine of, leave the inside the same, x divided by 2, except then I'm going to multiply by a half. Okay? Because the derivative of x divided by 2 is 1/2. Right? And so then I could probably simplify this. I could probably call this negative sine of x divided by 2. And then when I go to take the second derivative, I'm going to have, well, the derivative of negative sine is negative cosine, leave the inside the same, and then multiply by the derivative of the inside. Again, the derivative of x divided by 2 is 1/2. So I have negative 1/2 cosine of x divided by 2, which to me is looking like answer choice E. I think that's going to be all I have for you today. Here's a couple of other good problems from your multiple choice packet, number 16 and number 18. I've got the key up on my calendar, on the solutions page. I think what I will do is I'm going to show you the answers to these right now so that you can just pause the video and see if you're getting the right answer. All right, there you go. There's my work for the next couple of them. If you got any questions about this, you can definitely come see me in the morning or, send me an email or something. But otherwise, you really need to practice. So happy practicing.